Hello everybody, welcome to this YouTube channel where we're going to learn more about how to write code in R and specifically application cases where we see how we can basically get insights out of data. So happy for you to be here, and I'll be making mistakes, I'll be learning together as we see how to make the best of the tools that are out there. So I'm using R version 4.42, and as you can see, I've already created what we call an R markdown, and I have my data here. It's tbburden_country.csv. So this is an open source data source that I have got from Tableau. So health dashboards, blah, 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 tuberculosis burden by country, estimating the prevalence and mortality of tuberculosis by country. And the source is World Health Organization. So first thing, I'll just clear everything here and probably go to, I don't know, introduction. So I'm not writing any text, but just keeping note of the data that I have. And first, I'd like just to see what variables are in this data set. So I will say read in the data, and we'll name it burden, and then say read.csv, which is a function that you use to read data. And because my data set is in my working directory, I'll just copy the name as shown, which is tb_burden country.csv. So if I run that, it shows that it's been successfully read and there's no error. The next thing is to get a glimpse of the data, basically to see what variables are in this data set. And in this case, I'll use the head function and say burden. Yep. Then I'll run that, and you see it shows country or territory name, character code, yeah, blah blah blah, region, estimated population number, estimated prevalence. Okay, right. So what I usually do just to get better column names, I use a library called readr. So library readr, which I believe usually reads the column names better, and the read CSV function is different from the other one, from the one in base R, because it has an underscore instead. So burden read CSV. So you see it gives more information about what we have. We have 5,120 columns, 47 column specifications. No, 5,120 rows and 47 columns, blah, blah, blah. And then you see, if you, let's minimize this. If you look at the column names, they're better readability compared to what we have. So that's why I prefer using readr rather than the base R function that that is available. So next, I'm going to just on the console get the names of the columns that we have. So burden, and there we go. So 47, and then I'm going to copy them. And then I'm going to go to ChatGPT, and then I'll ask ChatGPT, okay, so I have a data set that I would like to quickly explore, and it's about TB prevalence by country, and is provided by WHO. And then please please brainstorm 4 ideas on how I can explore this data. Then I will select the option that I like. So, and then we copy paste the names of the columns that we have, and then run this. So you see, since this contains rich multidimensional information, blah blah blah, HIV co-infection, these are 4 ideas to explore. So first is global and regional TB trends over time. What to do, time series, okay. And then country ranking dashboard. And then TB and HIV co-infection patterns. Okay. And then methodology audit. Okay. Okay. So I think I'll just for this video I'll just stick to the first option. So I like the first option. Could you please explore what kind of research questions we can answer from this data? Can uncover several words. So general trends, comparison between indicators. Okay. Region, which region have the most uncertain data, how accuracy. So you see there's a lot here. Okay, so let's start with basic questions like general trends. So let's start with general trends, and then we can start by cleaning the data. So these are the questions. How have global TB prevalence, incidence, and mortality rates changed over time? And then also, are we seeing any consistent progress or fluctuations? And do these indicators tell the same story? So cleaning steps that ChatGPT suggests, it's data focus on prevalence, mortality, incidence, and also the metadata such as year, region, and country. So, and it gives like a very quick summary of the cleaning tasks that we can look at. So remove irrelevant columns, filter on missing or non-country records, and then convert columns to numeric, aggregate data for global trends. So we are using R. Let's go. Okay. Let's go step by step, and I will try out the code on my machine. Right? So it gives load and inspect the data, and then which we have already done actually, and then so what I can just do is just copy paste the title and say instead of introduction I write step 1, load and inspect the data, and then we go back. Step 2 is basic cleaning. Basic cleaning, And the idea here is to clean the data and focus on relevant metrics, and also keep only the relevant columns. So the reason why I'd like to keep this is just to organize the result in a way that makes sense. So I'll put this as heading 2. So what do we do? Create a new code chunk, and then let's copy what ChatGPT is suggesting, saying we keep country or territory, region, year estimated. Okay, and then rates bar. Okay, so go boost that. Be clean. So if we are keeping only relevant, so our data here is named burden. So we'll just burden, and then let's just follow what ChatGPT is saying. So first option is to use select. Select is a function of a package called dplyr, which has not been loaded yet. So what we do is introduce load library or package library dplyr, and then filter columns. So yeah, we can just keep tb clean. I think it's a better way to name objects in R. So burden, and then we say select, and then we say we are using, basically killing two birds with one stone here. We are saying select, and then using the country or territory name, but renaming it to country. So it's basically select and rename columns, and then region, year, population, prevalence rate, also mortality rate, incidence rate, and that. And then we can check the result. Check the result. So if we run this, yeah, these are just messages, but doesn't check the result. Sorry, head tb clean, and then run that. Now you see we have like a more tightly packed data set, specifically focused on the suggestions given by ChatGPT. So that's how we get the relevant columns. If we move to the next step, so it works, it's good. We are looking at converting columns to numeric, and this goes overall. We can also convert some to what we call factor, which is similar to category. So if we convert columns to numeric, sometimes numeric columns are read as character due to formatting. Yeah, that's right, as numeric. Okay, so we are taking, so converting columns. So this most of the time goes to your judgment. For example, something like country should be a category, region category, year can remain numerical, population numerical, rate, yep. Okay. And then we can name it as tbclean2 because we are making a change to basically making an adjustment to the original data set. So we are saying mutate, and then we are saying across. So what does across? So if you want to check and understand what the function means, you go to question mark across on your console, open that, and we see across makes it easy to apply the same transformation to multiple columns, allowing you to use select semantics inside data masking. Okay, so what we're telling R is mutate these columns to numeric format across year, population, prevalence, mortality, incident rate. And then the other thing we wanted to also do as numeric, I'm not sure if it's necessary because I see the double format can be used interchangeably with numeric, but yeah. So change categories, we say region. So mutate. At the beginner level, I think it's fine to have separate this for each task that you're asking R to do, separate it into one line of code. So we can say as factor, region, and then the other thing we wanted to change was country. Well, country could also remain as a character at this point. I don't think it will make such a big difference. If we run this and then we check again, and glimpse data glimpse TB clean 2. So if we run this, now you see only region has actually changed. There's no no major difference of what ChatGPT has asked us to do. So at some point, if you are revising this code, you can probably just leave out this part. But at least the regions have been changed to factor. Then we go back, we say remove missing or zero values. Okay. Remove, sorry about that. Okay, remove missing or zero values. So it's a process, just trying out and trying to understand what the code that is given is actually doing. And we see if so goal here is to remove missing or zero values. So typically, so what is key is this syntax here saying you're basically telling R to filter the column here, look at all the values that are not available or are NA, and then this exclamation mark is to basically say remove them but only keep what is not NA, and then here for population just keep populations that are greater than 0. So this is based on suggestions by ChatGPT. I don't know if it will make such a big difference, but we can check, because if we basically use range TB clean and then look at population just to check if there were any values that are less than 0, we see the lowest is 1129 and the largest is that value. So basically this code is not really, it's more like procedural ways that you do for other data sets, but this one doesn't really make a difference. But it's good to take it through and just make sure that there are no values. The other thing we can do is to check the dimensions of TB clean 2. We see it has 5,120 rows, 7 columns, and then check TB clean 3, and we see it has the same number of rows, same number of columns, which means this basically this chunk of data has not done anything of value, but it has allowed us to rule out the possibility of the presence of like NA values, missing values, or even values that are 0. So we're good. So we tell it, let's go to the next, which is aggregating. Okay, aggregate for global trends over time. Mm-hmm. 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 So we'll calculate global population weighted average for the TB rates across all countries. Okay, so and another title heading, if you'd like, and then introduce a new code chunk. Save that, and we see first step is to compute weighted averages by year. So like that, yes. Copy this chunk of code, and then we introduce a new object. So aggregating, introduce a new object called global trends, and we are using our, because this part of the code did not do anything, we can just take it from tbclean2, so it will still be fine. And then we say group by year. So what's group by? Group by, group by takes an existing TBL is a table or a data frame, takes an existing table and converts it into a grouped table where operations are performed by group, and grouping removes grouping. Okay, so what we are saying is we are taking tbclean2 and then we are grouping it by year, say into subsections. So 1990, here are your values, 1991, here are your values, like that, like that. So we can just add a comment here and say grouping by year. And then we go to summarize. So what is summarize? What is this summarize? So summarize creates a new data frame. It returns one row for each combination of grouping variables. So we've grouped the variables and then we are saying for each group give me a summary. Okay, so summarize by group, and then we say, so global prevalence is weighted mean. So we have weighted mean. What is weighted mean? Compute a weighted mean. Okay, let's ask ChatGPT what is weighted mean explained in layman's terms. So a weighted mean is just like an average, but it gives more importance to bigger values, like bigger countries in your data set. Okay, so the weighted mean reflects what is really happening to the average person, not just the average of two country rates. So in this data set, when you calculate global TB rates by year using a weighted mean with population, gives much more accurate picture of the global situation, rather than letting small countries skew the result. Perfect. At least now we have an understanding of that. So we are going to weight the means of prevalence rate, mortality rate, incidence rate, and population. No, for population we're just going to get the sum and then we ungroup this. So then we'll have to check. So ungroup, removes grouping, as you remember what we saw here. So get glimpse of the summary. So we see of And then na.rm means remove NAs or remove missing values so that it doesn't skew the weighted mean. And you see the common string across all this is population, because we are using the population to calculate the weighted mean. Right, so you see the year global prevalence across the years, 28, 150. Okay, that's good. So we go back to so we've done the weighted mean. Now we go to visualize trends over time. Okay, so visualize over time, and then we copy this, create a new chunk, copy paste. We have to load the ggplot, so library, because it will help us to visualize. And then it says reshape to long format for easier plotting. I think let's just separate this. Global trends long, and then global trends pivot longer. So what is pivot longer? No, okay, Jumbo. Pivot longer. Let's use this one. So pivot longer lengthens data, increasing the number of rows and decreasing the number of columns. Okay. Okay. Just for quicker understanding, so how would you explain the function pivot longer to a layman? So imagine you have a table, in this case like a data frame with a bunch of columns, maybe one for prevalence, one for incidence, and one for mortality, like this. Okay, this is called the wide format because the different types of TB data are spread out across columns. Okay, now what pivot longer does is this. It reshapes the table so that all TB metrics go into a single column with an extra column to label what each row is about. So it becomes, for the year 2000, prevalence 250, 2000 incidence 300, 2000 mortality 100. Okay, now it's long format. More rows, fewer columns, but you still keep the data that you have. And why do we use it? It makes it much easier to plot or analyze different metrics using tools like ggplot, which love data in this long format. So a simple analogy, imagine you're turning separate columns of apples, bananas, and orange into one single column called fruit type with another column for quantity. You just organized your fruit basket. Now it's easier to sort or plot. Okay, yeah, I think I get what they mean. So we are saying pivot longer, and there's an argument saying calls. So let's see. So calls basically specifies the columns that you'd like to pivot to longer format, and it says those that start with global. Okay. And we see it is from, so this is usually the function and the package, which means we have to load this one as well. And then we change the names to metric and the values to rate. So if you run this, then we check out the data. No. check data. Global trends law. Right. So you see here total population matrix rate. Right. Okay. 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 Then we go back to the next section. That's basically plotting. And no, just to go back. So starts with, yeah, let's see what this starts with. Okay. Nope. This one. Nope. This selection helps us match variable according to a given pattern. So starts with specifies columns that start with an exact prefix. In this case, the prefix was global underscore. So that's why we put, okay, starts with. Right, got it. So for plotting, we are going to plot a line graph. And we have our data set here. And then we are specifying that on the x-axis, horizontal axis, we are going to have the year. And then on the y-axis, we are going to have the rate. And then the color is going to be the metric, which could be either global prevalence, global mortality, or global incidence. Then we add line plot. And then labs. So labs are the labels of the graph. In this case, the title, the year for the x-axis, and the rate per 100,000 people for the y, and then the color for the metric. Then theme minimal is a type of theme that strips down the graph to as clear as possible. So if we run this, okay, warning, using size aesthetic was deprecated in ggplot 2.3.4. Please use line width instead. Okay, so they say line width. Not a must, sometimes you can keep it out. Alright, so global trends in TB rates per 100,000 population, and then the rate. Okay. Okay. So first impressions is global prevalence was at a plateau at least until 1998 or something, and then it has been going down since then. Global incidence plateaued until 2005, then we see a slight drop until what is, so max GG, no, global trends long. I want to see the latest year in the data set. So here, oh, so it's up to 2013. It's not really recent data. That's like 11 years ago. So, but yeah, just for purposes of understanding this, yeah. And then global prevalence. No, global mortality also plateaus, but we see a drop from 2005 to 2010. So just to understand this, probably I can ask. Wait, what was? Yeah. So what is the relationship between incidence, global incidence, prevalence, and mortality? So incidence is the new cases in a given time period. usually per year. Like how many people catch TB this year? Okay. Then prevalence is the total cases at a specific point, like a photo of everyone who currently has TB right now. Okay. Then mortality is deaths from TB in a given time period. How many people died from TB this year? Okay. How they relate to each other. Think of a bathtub as a metaphor. Water flowing in is the incidence. Okay. Water sitting in the tub is the prevalence. Okay. Water draining out. Oh wow, yeah, that's actually very interesting. Water draining out is the mortality recovery. So water draining out is mortality or recovery, but in this case we are focusing specifically on mortality. So if the incidence is high, if the water flowing in is high, prevalence will rise unless offset by cures, people recovering, or deaths, people dying. If mortality increases, prevalence can decrease, but for bad reasons. Okay, people are dying instead of getting treated. If incidence drops, fewer new cases and more people are cured, prevalence and mortality will also fall over time, which is what we want in public health. Key relationships, okay. So in your TB data, if incidence is decreasing but prevalence isn't, maybe treatment isn't curing people fast. So in my data, I see prevalence is decreasing and incidence is also incidence decreasing, but prevalence isn't. Prevalence was what? Prevalence was yeah, the amount of people. Okay, so prevalence is good, but okay, incidence is high, more water. Incidence, water flowing in. Prevalence is decreasing. Okay. Yeah, but we don't see like mortality going up, which I think is a good thing because it means more people are being treated. Okay. The other option we could do is to place the legend at the bottom of the graph. So theme legend position bottom. We run this. Yeah, I think it is yeah, good. Right. Okay. And then we go back. So we've seen comparative line chart of prevalence over time, TB prevalence, incidence, and mortality rates over time. Okay. Yes. Check correlation, plot each pair of indicators. So here we want to see the relationships between these three variables as a next step, just to see if there's any specific relationship that could make sense. And we see plot each pair of indicators. Okay. Yep. Oh wow, yeah, okay. So let's do it one by one. So scatter plots are used to compare the relationships. We already loaded this library, so we remove that. And then we use the global trends We'll not use the long format, we'll use the wider format of the data. That's why we use the global trends data set or data frame. Then on the x-axis we say global incidence, on the y-axis we say global prevalence, and then we say geom point, which is basically how to add the scatter plot. Then geom smooth. So it aids in the eye seeing patterns in the presence of overplotting. They both use, okay, and then we put labs, as I'd said, that's for title, x-axis and y-axis, and then we use theme minimal. So if we run this, okay, interesting. So we see a clear positive or direct relationship between incidence and prevalence, suggesting that increase in incidence will increase prevalence. Okay, yeah, makes sense. And then one thing that we can do here from the statistical point of view is to calculate the correlation coefficient. So we say core test, and then we say global trends. Then we are saying incidence and global trends prevalence. So we already see it's a positive. Let's run this. So Pearson's product moment correlation, we see p-value is less than 0.01. Correlation is 0.94. That's quite high. And yeah, let's see what ChatGPT says. What does this result mean in a simple way? Mm-hmm. 0.94. So there's a very strong positive correlation. As incidence, new TB cases increase, prevalence, total current TB cases also increase, and they rise and fall together very consistently, which is good. The p-value, okay, this is a very real and strong relationship. Got it. Then for the next one, it's prevalence versus mortality. Basically the same code, you just change the global mortality. Okay, this is also quite yeah, let's do the correlation test. Okay, copy this, copy. But now we are saying mortality, prevalence, yeah, mortality. Wow, 0.999. Okay. What about this? I know, it's a strong correlation. When prevalence goes up, mortality goes up almost exactly in step. Okay. Mortality depends a lot on how many people currently have TB. If more people are sick with TB, unfortunately more people might die from it. Since mortality and prevalence track so closely, it suggests that deaths come mostly from the existing pool of TB cases. Think of prevalence as the size of a fire and mortality as the amount of smoke produced. The bigger the fire, the more the smoke. So almost perfectly. Okay. And then the last one is incidence versus mortality, and if we look at if we look at the correlation as well, yeah, also somehow somewhat positive mortality or direct. Yes, it is. 0.94. Okay, so higher incidence, higher mortality makes sense as well. Right, so we've checked correlation, we've plotted this, and we basically finished that section, and we have a pretty good idea of what's happening. So that's how to explore data and basically see what the patterns are and probably shape the type of questions that we can ask. We are going to continue with this data set or a different one in the next video. Thank you so much for watching. If you have any comments or suggestions on how to improve this, please let me know in the comment section. Subscribe and support my work, and looking forward to the next one. Bye-bye.